In this video, we are going to learn how to solve these chemistry problems under equilibrium system in chemical kinetics. So guys, we have 9 repeated questions to practice with. In this video, let's get started. The first question I have here says, consider the equilibrium reaction below. So we have the amount of sulfur 6 oxide produced will increase if the temperature is reduced, if the pressure is decreased, if more heat is applied, a catalyst is added. So the right answer to this question will be option. Okay, sulfur 6 oxide produced will increase if. So guys, the right answer to this question will be option A. The temperature is reduced. This thing is meant to be sulfur 4 oxide, not sulfur 6 oxide. But there is a slight mistake here. So this is exothermic reaction. In exothermic reaction, increase in temperature will favor the backward reaction, causing the equilibrium position to shift from the right to the left. So what we have here is sulfur 4 SO2 sulfur 4 oxide. So when you decrease or reduce the temperature, it will cause more of this SO2 to be produced. Alright, so that's for this question. The next repeated question will be this one. It says, consider the following reaction equation. If the temperature of the system is increased, so this is endothermic reaction. In endothermic reaction, increase in temperature will favor because the equilibrium position to shift from the left to the right, favoring the forward reaction. So we have reaction will stop, forward reaction will favor. Yes, the right answer is option B. Alright, so backward reaction will favor no. Since it's endothermic, forward reaction will be favored. Even this is exothermic, the backward reaction would have been favorable. But in the case of endothermic reaction, increase in temperature will favor the forward reaction. Take note of this, guys, very, very important. Next subject question with this one, it says, which of the following statements about an equilibrium system is correct? The concentration of the reactants and product can be changed by adding a catalyst. No. Forward and backward reactions occur at the same rate. Yes. The concentration of reactant must equal that of products. No. The concentration of reactant and products are not affected by change temperature. So guys, in the equilibrium system, forward and backward reaction occur at the same rate. So that's it for this question for option B. The next subject question will be this one. What is the effect of using vanadium 5 oxide as catalyst in a reaction represented by the following equation? So this is a catalyst, vanadium 5 oxide. It says reduces the time for attainment of equilibrium, increases the collision rate of reactant particles, decreases the value of changing H, which is our enthalpy change, heat of chemical reaction. We have shifts equilibrium position to the right. So the right answer to this question will be it reduces the time for attainment of equilibrium. So you know that what catalyst does is that it speeds up the rate of chemical reaction. So speeding up is going to reduce the time for attainment of equilibrium. So that's for this question. The next question in this one, it says the spontaneity of a chemical reaction is determined by change in where pressure applies to the system, concentration of the reactant, temperature of the system, free energy of the system. So the right answer is option D, free energy of the system. That's it for this question. The next question with this one, it says the position of equilibrium in a reversible reaction is affected by reaction in concentration of reactant, presence of a catalyst, vigorous stirring of the reaction mixture particle, size of the reactant. So guys, the right answer will be change in concentration of reactant. So according to the Netherlands principle, temperature, pressure, and concentration of reactants can affect a position of equilibrium. Okay, so the right answer is option A. The next repeated question will be this one. It says consider the equilibrium reaction represented by the equation. So this is exothermic reaction. Always look at the type of reaction you are dealing with. If this is a negative, is exo. If this is positive, is endo. Alright, so the knowledge of this will help you to get the right answer to the question. Here it said at equilibrium, increase in total pressure the system brings about. So increase in total pressure we have decrease in temperature of the system. We have increase in concentration of SO2 sulfur 4 oxide. We have decrease in the rate of reaction of the system. We have increase in concentration of SO3. So guys, increase in total pressure here is going to cause increase in, okay, let's take, we have how many moles of gases do we have here? At the left we have 2, 3. At the right we have 2 moles. So when you are dealing with pressure, according to electrical principle, we are considering the number of moles of gases. So since we have less number of moles at the right, at the product side, this SO3, so increase in pressure will bring about increase in the concentration of SO3. Alright, I think it was decrease in pressure, the answer would have been it will increase concentration of SO2, but since it's talking about increase in total pressure, we favor the side with fewer number of moles of gases, whereas decrease in total pressure, we favor the side with more number of moles of gases. Very important, guys. Let me say it again. When you are dealing with pressure as a parameter, increase in total pressure favor the side of the reaction with lesser number of moles of gases, whereas decrease in pressure will favor the side of the reaction with more number of moles of gases. So in this case, increase in total pressure will increase the concentration of SO3 with fewer number of moles of gases. We have 2 here at the right side, and we have total number of 3 at the left side. So that's for this question. Let's play question with this one. It says, consider the equation for the equilibrium reaction. The equilibrium constant for the reaction can be expressed as, so looking at this, the right answer to this question will be this option D. Alright, case C will be this. So yeah, basically the product is usually the numerator, whereas the reactance used to be the denominator. Okay, so this will be the right answer to this question. Next will be the question will be this one. Option D, the right answer here. Next will be the question will be this one. This is the last question. It says, consider the reaction represented by the following equation. Finally, the violet ion is used as catalyst in a reaction in order to increase the time for attainment of equilibrium. Option A, no. Shorten the time for attainment of equilibrium, yes. Decrease the yield of ammonia, no. Lower the value of the change in H, that's enthalpy, no. So the right answer is option B, shorten the time for attainment of equilibrium, because catalyst speeds up the rate of chemical reaction, so again shorten the time. So guys, this basically can do a problem involving equilibrium system chemical kinetics for chemistry practice with 9 repeated questions in this video. Hope you learned something interesting from the video. Let's go to the video, guys. If you are new to this channel, make sure that you subscribe to this channel by hitting the subscribe button for more of these videos. Also like, share, and comment on this video. Let me know if you for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to be a question in the comment section below, and I will be sure to give you a response. Also ensure that you're part of the channel membership by clicking the join button, where you'll be getting premium information that will help you to excel in the exam you'll be writing. Alright, so having known this, click the link above, and I will see you in the next video. Thanks for watching.